Hello everybody. In this video we'll present a new feature in Strap 2022 for defining a wall from a predefined mesh of shell elements. Let's see an example. On the walls, a new option called Element Wall is available. After clicking Element Wall, we'll be asked to define the wall contour. The first selected node will set the wall's baseline start. The second node will define the wall's baseline end, and two more nodes to close the wall's contour. We can see that the shell element's surface now is a wall. This definition doesn't affect the model's stiffness and doesn't affect the analysis results. This definition will only help the user to view wall results for the defined wall and to design it in the reinforced concrete design module as well. Under Output, Display Wall Data, Wall List, we can see information about our wall, and we can see that the wall number is 1. The baseline nodes are 106 and 107. Node 108 and 109 are closing the wall's contour. The wall's area is 20 square meters, the height is 5 meters, and the volume is 5 cubic meters. Under Display Local Axis, we can see the wall's local axis. The x-axis is always at the direction between the two base nodes of the wall, and the y-axis is perpendicular to the x-axis. Once we define element's wall, the option Revise will be available. Clicking Revise will allow two options. The first is to revise the wall contour, and the second is to split the wall to several parts. When selecting Split, the program will allow us to select nodes along the baseline or the height line for splitting the wall. We'll move on to the Loads module. We'll define a 10-ton joint load at the top level of the wall in the X1 global direction. In the Loads module, the definition of shell elements as a wall is meaningless, and loads are applied to the elements as we know it with all the options that are available for elements. Let's solve the model. Under General Results, Draw Results, we'll select Wall Results. The available results are moment in X, shear in X, axial force, moment in the Y direction, shear in Y, and torsion. Let's display the moment in the X direction. We can see 50 ton meters, which is the 10 tons at the top level of the wall, multiplied by 5 meters, which is the wall's height. We can also see 10 tons of shear force in the X direction. Let's move on to the reinforced concrete design. Under Walls, click Compute. We can see the wall's results summary with the calculated reinforcement and the wall's capacity factor. Right-click your mouse when hovering next to the wall and ask for detailed results. At the top, we can see a side view of the wall and the wall's thickness. Underneath, we can see the detailed results and the calculated reinforcement. This simple example helped us to understand the basics of Element's wall. Let's go back to see more complex examples. In this example, we have Element's wall with a variable width along the height axis of the wall. Prior to the element's wall feature, this wall shape wasn't available in Strap. With the regular wall element, this definition isn't possible, since the wall element option allows the definition of a wall section, and the section can't vary along the wall height axis. So in this example, we define the element's mesh, the element's thickness, and we define the elements as element's wall. Let's move on to the loads. We can see two load cases. The first is a 20 tons horizontal joint load, and the second is 3 vertical 10 tons joint loads. We'll solve the model, and we can see the wall's results. Let's look into the moment in the x direction for load case number 2. We can also see the axial force. For element's wall, we can also see element's results. This will allow us to better understand the wall's behavior. For example, displacement at each node, or a contour map of the vertical forces. Moving on to the reinforced concrete design. While computing element's wall, Strap considers 3 lines of wall results. The first is at the baseline, the second is at the wall's middle level, and the third is at the top level of the wall. So basically, it has 3 lines of wall results from the analysis. The considered wall section for calculation is the smallest section. In our case, it's the section at the wall's base. So in this case, the program will consider the baseline section with the worst wall results between the baseline, the wall's middle, or the wall's top level. In this particular case, the worst results and the smallest section both are at the wall's baseline. But in other cases, this might not be true. So to get a more economic design, the user will need to split the wall along its height axis. Looking into the detailed results, we can see that the section that was taken under account is 300 centimeters long and 30 centimeters thick. Design combination 3 is the design combination. The axial force is 48 tons. The moment in the x direction is 316 ton-meter. We can also display the wall drawing with a vertical reinforcement. Let's see another example. We can see a wall with openings. We can define the whole element's mesh as a wall, or to define walls between the openings for a more accurate design. In this example, we'll define several walls between the openings. First, we'll define the first wall from the bottom to the top. And we'll use split to split the wall along the height axis. We'll repeat it for the rest of the walls. For the coupling beams, we can define them as elements wall with a vertical baseline, and the height line will be horizontal. By displaying the local axis, we can see the wall's orientation. In the loads module, we'll define one load case with 10 tons joint load at the top level of the wall in the x1 direction. Displaying the moments in the x direction, we can see the result on the walls and on the coupling beams. We can see the shear force in the x direction and the axial force. Moving on to reinforced concrete design. Since we defined 3 strips of walls, we can see the design for each wall unit. We can even see the detailed results for the coupling beam, although it's important to understand that it was designed as a wall with code requirements for walls. To summarize this video, we'll display a comparison table between the existing wall element and the new element's wall. Thank you very much for watching.